Okay, now my second skill is like I want to find the image of a point and like I want to find the matrix giving a description, no? So for example, here are the problems. I am telling you, I want what type of transformation I am talking about. I want an anti-clockwise rotation with an angle of negative 2 pi over 3, and I want the image of this point, no, of 5 comma negative 1. So if I want an anti-clockwise rotation, if I go to the formula booklet, anti-clockwise rotation is cosine, negative sine, sine, cosine. So that means that my matrix has to be, o sea, anti-clockwise rotation means that this is a cosine, negative sine, sine, cosine. My angle, it is given, it's being 2 pi, negative 2 pi over 3. So my matrix is going to be cosine of negative 2 pi over 3, negative sine of negative 2 pi over 3, sine of negative 2 pi over 3, cosine of negative 2 pi over 3. So you know, of course, if you're a pre-calc kid, you know how to find this. But like, let us find it like here with our calculator. Because my angle is in radians, o sea, I have a pi, that means that my calculator needs to be in radians, no? So let me ensure that I have my calculator in radians. So what is the cosine of negative 2 pi over 3? And what is the sine of negative 2 pi over 3? Okay, so that means that this would be, the cosine is negative 0.5, the sine is negative 0.86. So here I am going to put it positive 0.86. 66. Because positive, because I am doing, perdone. So this one is negative, no? So I'm going to put it negative. And this one, o sea, this is minus 0.866. And because it has a minus in front, it's going to become positive. Then negative 0.866. And here, negative 0.5. So this is my matrix. This is a rotation anti-clockwise with an angle of negative 2 pi over 3. Okay? Now, I need to find the image of this point, so I need to plug it in. And what does plug it in means in the context of matrices? Well, in the context of matrices, of matrix transformations, to plug in means that I am multiplying a column vector. O sea, it means that I am multiplying by the vector 5, negative 1. O sea, this point, I am writing it as a column vector, and I am doing like a multiplication of this matrix times this matrix. Of course, we know, o sea, this is the meaning of evaluation, no? O sea, this means evaluating at 5 comma negative 1. O sea, and that is how we do it, no? This is how we do it. We multiply, o sea, we turn the row, o sea, we turn this point into a column vector. I know I hate it, but this is how we do it. Like, why is counterclockwise positive? Why is negative to the left and positive to the right? Why do we do all of those weird things? This is a mathematical convention. A point goes as a column vector. Okay, so this is an operation that we can do here in our calculators. How do we do it? I go to menu, I go to matrix, I create a matrix, I create a 2 by 2 matrix, which would be negative 0.5, 0.866, negative 0.866, negative 0.5, and I am multiplied by a matrix, no? O sea, I already have this, and now I want to put the green part. So to put the green part, I go to menu, matrix vector, create a matrix with 2 rows and 1 column. And I want to multiply by 5, comma, negative 1. I don't have to specify what type of product is it. It is a matrix product. And that is my answer, no? O sea, that means that when I evaluate this point, is going to be a negative 3.366 and negative 3.83. O sea, and what does this mean? This means that if I rotate this point by the origin, by this angle, my point is going to end up here, which is, o sea, that is what we're doing, no? O sea, we are rotating this point by this angle, and this is the final coordinates, no? O sea, the final coordinates are negative 3.366, negative 3.83. These ones are my final coordinates, no? But I write it as matrix, as a column vector. Okay, for the other one, I am giving you a reflection. So in this reflection, so it is a reflection with a line of, o sea, a ver, this is a reflection. The meaning of reflection is that I have a matrix that is cosine of 2 theta, sine of 2 theta, sine of 2 theta, negative cosine of 2 theta. Okay, and it is by the line y equals negative 2x, and we know that this is y equals to the tangent of theta x. So I can find, o sea, I want to find what is theta. What is theta? Well, if I know that the line is tangent of theta x and this line is negative 2x, so from here I can write the equation a tangent of theta equals to negative 2. I go to my calculator. So I go to trig, inverse tangent of negative 2. I want my answer in degrees, no? Because I prefer degrees and radians. I write my answer in degrees, and that is theta is the angle negative 63.4349. I have a feeling that this is like 2 pi. A ver, if I do it in radians, no, nothing. Let us keep it in degrees. So that means that theta equals to negative 63.4349. Now, to find the matrix, I just plug in this in here, no? So it would be cosine of 2 times negative 63.4349, a sine of 2 times negative 63.4349, sine I, and this one is negative. So this is my matrix, no? And I can plug in this one into my calculator. Let me do that very quickly. O sea, I just need to know what is the cosine of 2 times negative 63.4349. And I need to know what is the sine. So I'm going to round it up, no? So this is going to be negative 0.6, negative 0.8, negative 0.8 is 0.6. So this is a matrix that corresponds to, this is a matrix that corresponds to the reflection, no? this is a matrix that corresponds to the reflection. So to evaluate this point, it would only mean that I do the multiplication, negative 0.6, negative 0.8, negative 0.8, 0.6 times, for example, in this case, with the vector negative 4, comma 2, because I always do it with a column vector, so I'm just going to put it here. O sea, this is the vector 2, 4, negative 4, and this matrix is the matrix 0.6, negative 0.8, 0.6, negative 0.8. And so that is my resultant vector, no? 0.8, 4.4. And so, okay, and for example, if I want to do a vertical stretch is only having like the 3/4 in here, 0, 0, and 1, no? And to find the image is just multiplying it by negative 1, 2. Ay, perdón. Sorry, for the next problem, consider a vertical stretch. A vertical stretch is like this, because if you go to the formulas, I know that vertical stretch is like this, no? That is why it's fantastic to check the formulas. Because I don't know if you see it, but I wrote it wrong. O sea, it should be 1 in here and 3/4 in here. No? Okay. So that is my second skill. Woo, math!